I had a few folks asking me about our upcoming IXL assignments from the pre-calculus section, F16 and F17. So in this video, I'd like to work through a few samples from each. Now I'm actually going to start with F17. I'm going to start here because I noticed that the first few questions actually provide you with an equation to start with, and F16 didn't do that. So we're going to start with F17 and I'll show you a little bit about it. What you're going to see in each of these sections ultimately is practice with an exponential equation. And we call these exponential equations because the variables, or there are variables here written in the exponent. So I've got two letters written in the exponent in this particular case, but in F16 I believe we're only going to have one variable written there. So this formula, A equals P times e to the RT power, is what we call a compound interest formula. And this tells us that the total amount of an investment that started out worth P dollars, this is the principal or beginning amount, when invested at a particular rate for a given amount of time, where time is length of time in years, again, we can determine what that amount would be after the investment is left alone. So in this case, Becky has $500. She's putting it into an account for school expenses. It earns 7% interest per year, and it's compounded continuously. So this phrase, compounding continuously, is what indicates that we would use this equation, the PE to the RT power. So we'd like to know how much the account is worth after 9 years. So this really isn't too hard. We have a lot of information here. We can calculate the ending balance or the amount that the account is worth. So again, we started with $500. That's our principal amount. We multiply that times E raised to the rate times time. Now, rate was given to us as a percentage, but we should write that as a decimal. So 0.07 times time, which in this case is 9. So I say that this first problem is actually pretty easy because there's no solving for variables over here. We've already got our unknown isolated. We just need to enter this into the calculator. Here's what the equation would look like when written in our TI Inspire calculator. Notice that this letter E is a bold letter E, and I got to that I got that value by using this button here on the calculator. So when you're using the natural base E, make sure you use this key and not the letter E from the keypad down below. So after we complete this calculation, we see that our $500 at 7% interest compounded continuously for 9 years turns into $938, and we'll round that to 81 cents. 938.81. So let's go ahead and check that answer. 938.81. And it looks like we did okay there. Here's another problem that looks very similar. $300 principal, so this is our starting investment. 5% interest compounded continuously. We're looking for the balance after 4 years. So this is the exact same setup with new values. And in fact, we're reminded that this is the formula to use. And here's the expression in the calculator. $300 compounded continuously at 5% interest for 4 years will be worth $366.42. So let's check that. That looks pretty good too. Here's another example, essentially the same. $800 is invested, earns 6% interest compounded continuously, and this couple wants to use the money to go on a trip in 2 years. So we want to know how much that is going to be worth. Go ahead and pause the video and try this one on your own. See if you can get the answer that'll work. I'll come back in a second and check my answer. So it looks to me like the $800 will turn into $901.997. Now, of course, if we round this to dollars and cents, the 7 rounds the 99 up to the next dollar. So let's go ahead and call this $902. $902.00. And that looks pretty good. Now we see a slightly different equation to be used. We're up to 28 points after 3 problems, and we see a new equation here. Now this is quite similar to what we saw a few minutes ago. We're starting with a principal amount. We have a particular interest rate, and we're investing money for a certain length of time. The only difference here is that we're compounding our interest only 12 times per year, or monthly. In the last example, we were compounding our interest continuously, or an infinite number of times each year. And sometimes banks will calculate that interest for you that way. This time, they're essentially saying that we're only going to compound interest 1 time per month. And because of that, whether we're compounding monthly, or maybe we're compounding daily or weekly, or some other discrete value, because of that, we have to use a slightly different formula. But it still works out the same. We're going to input 200 in place of P. We have our interest rate R. We'll write this 12% as a decimal. What is different here is that N is the number of times that we compound our interest, and T is again our time. So I'm going to set this up into the calculator so that you can see what it looks like. And here we have it, $200 with a set of parentheses. So $200 multiplied by 1 plus our interest rate, 12%, divided by the number of times we compound per year, so 12 times per year, raised to the power of N times T, so 12 times 3. It might be helpful to think of it this way. If we have our investment left alone for 3 years' time, and interest is calculated 12 times per year, this 12 times 3, which is 36, tells us that the bank would help us calculate interest 36 different times over the life of the loan. I'm not sure if that helps you understand the process a little bit more, but that's exactly what's happening here. So it looks like our $200 turns into $286.15. So let's check that answer. And $286.15 appears to be a good result. I'm going to work through a few more of these problems to see if the set of instructions change. We're only at 36 points right now, so I have a feeling that it's going to change a little bit. In fact, I expect us needing to solve for N or T here shortly, and for that we'll likely use logarithms. Okay, so I've made it up to about 49 points, and I see that the question starts to change. Oh, by the way, along the way, I found different rates of compounding. There were some questions where we compounded annually or quarterly. If you're completing these problems and you're not quite sure what the end value would be for the number of times that it compounds, I'm sure you could probably figure it out, but if you're not willing to make a guess as to what the end value needs to be, go ahead and do a Google search. I bet if you search for the phrase compounded monthly, compounded annually, compounded quarterly, you'll find a website that'll help explain all those different options. Well, here's an interesting question. Ian earned some money doing odd jobs last summer and put it into a savings account that earns 10% interest compounded monthly. After 6 years, there is $487 in the account. So we'd like to know how much money Ian earned doing his odd jobs. So while we're still using the same equation from before, we've got the equation A equals P times 1 plus rate divided by N raised to the NT power. What we know this time is that at the end, after the money was invested, after he put the money into the savings account that grew with interest, he finished with $487. So he finished with $487. We don't know how much he put aside, the principal at the beginning, and we know that the interest rate of 10% was compounded monthly for a total of, I think they said 6 years, 12 times 6. So our job here is to solve for P. Now, I'll let you in on a little secret here if you don't notice this already. What I've just captured in the blue brackets here, if I were to go to a calculator and punch that in, it would just be a number. So essentially what I have is the principal amount times some number. And if I wanted to get the principal value by itself, then I would just divide both sides by that number. And our calculation would end up look something like this. P isolated by itself would be $487 divided by 1 plus 0.10 divided by 12 raised to the 12 times 6 power. And this is something that you can enter into the TI calculators in one step so that you don't have to worry about rounding this decimal along the way. And so our entry in this fraction, you'll notice that I built the fraction first and then entered all the data points along the way. It appears that he would have invested $267.94, and that's what turned into $487. So let's give that a try. 280 or 267.94. So let's see. Okay, good. It looks like we did that one just fine. This next question is just the same. So I'll finish it and work forward until I see a slightly different equation or style of equation. I only made it one or two questions down, and I almost checked this answer, but I thought I'd show it to you. This one's similar to the last, except this time we're compounding continuously. So let me remind you that the continuous compound formula is the one that looks like this. The amount is equal to our principal times e to the RT power. In this case, $206 is equal to some principal, some starting amount, times e raised to the power of 0.1 times 3. Well, again, the number inside these blue brackets is just that. It's a number, so we could divide both sides by that number, and that leaves us with p. This expression in the calculator gives us a result of $152.61. So I'll keep moving on until I find another different style of problem. Okay, made it up to 75 points and finally found a slightly different question. Not drastically different, but the final question that they actually ask here is a bit interesting. 4 years ago, Eli won some money in the lottery and put it back into a bank account that earns 9.33% interest compounded annually. If Eli currently has $1,142.12 in the bank, how much interest has he earned? Now, interest, this is the term that we use to describe how much money has our investment earned. So not necessarily what the total investment is worth, but how much interest, how much extra money was earned. So the principal, or what he started with, was our ending balance, 1142.12, divided by 1 plus our interest rate. So this was 0.0933, compounded annually, so that's only one time per year, raised to the power of 1 times t. So we're talking about t was 4 years ago. So 1 times 4. If I complete this calculation, I'm left with a principal or starting amount of $799.38. So it looks like $799.38 was invested, and it's now worth this total amount. So to answer the question from the IXL section, we need to understand that interest is literally equal to the ending balance, or the amount that something's worth, minus the principal that we invested. So this is perhaps a new equation, especially if you haven't had any financial math before. Interest is equal to the ending amount minus the principal. So in this case, 1142.12 minus 799.38 leaves us with $342.74 earned in interest. That appears to be a good answer. This video is getting to be quite long, so I'm actually going to stop it here. We've made it up to about 78 points, so I'd guess that you'd make it to at least 80 or perhaps even 85 using all of the techniques from this particular video. I'll make another one to help us walk through some of the problems that you'll encounter in PreCalculus F17. Thanks for watching.